Pascal's triangle, take 6.
Whoa.
N goes down, right? N goes up as we go down.
Okay.
R or K goes up as we go to the right. Agreed?
Yes.
Okay. So, just as a matter of labeling, this first term here is like 0, choose 0, and then this term is 1, choose 0, 1, choose 1, 2, choose 0, 2, choose 1, 2, choose 2. You following me on
Yes.
the labeling?
Yes.
Okay. I'll do one more row in detail. 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. Okay. What we come to is n equals 4, n equals 5, and so on. The whole point of me labeling these carefully is I want to get all the way down to 15. Right?
Okay.
So let's count. 4, 5, now this is 6, 7, 8, 9, 10, 11, 12, 13. The boredom is almost over. 14, 15.
Okay.
Okay? Now, let's write the same thing over here. 15 should go right at this point. Okay. What was the whole point of me doing this? Was we have to identify where is 15 choose 4.
Okay.
That was the whole point of this whole counting thing on Pascal's triangle.
Okay.
Okay. 1, so 1, 2, 3, 4. This spot right here, this green spot that I've colored in is 15 choose 4.
Okay.
Okay?
Famous spot.
Right, famous spot. Where is 8 choose 4? I got to go to the 8 row, and then I have to say 1, 2, 3, 4. This spot right there is 8 choose 4.
Okay.
Why do we care so much about 8 choose 4 and 15 choose 4? Because we're looking at problem 13 point whatever that says we would like to figure out 8 choose 4 plus 9 choose 4 all the way up to 15 choose 4. Okay, so that's where we are. Agreed?
Yes.
What does the hockey stick identity tell you about this diagonal column of numbers? If I start from here and I add up everything and do my little hockey stick turn, I land at this spot. And now I'm using yellow, and you say it doesn't show up very well.
Yeah.
So I'll use a different color.
The blue shows up well.
Blue, this kind of blue?
Yeah.
Okay.
Shows up pretty well.
So if we add up all of these numbers in Pascal's triangle, whatever they happen to be, we get this number at the blue.
Okay.
That's what the hockey stick identity says,
Okay.
right? The hockey stick identity says start here, add up all these numbers, and it equals this. Start here, add up all these numbers, and it equals that. Miracle identity that works anywhere on Pascal's triangle.
So I could just swipe down and then like that.
Right. As long as you start somewhere here and you say, okay, this plus this plus this plus this plus
Well, you have
this.
to start on this line. Why can't you start? Okay, I like this point.
Well, it doesn't work. I mean, you know, I'll give you a really simple example. All right, that'll convince you that you can't do that. What are all these numbers in Pascal's triangle. These numbers meaning I have a 1, and then I have a 1, and then I have a 1, a 1, a 1, and a 1, right? What's this number here? What's this number in Pascal's triangle? Do you know? Well, it's easy to figure out if I go over here and I say, oh, this is n equals 6, right?
Mm-hmm.
So whatever number this happens to be, it's equal to n choose 1,
Okay.
right? That's what these numbers are. So I'll do it a different way. This is 1, right? And then one plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6.
7, 8, 9.
Right? 6 choose 1. Okay, now look at the hockey stick identity. The hockey stick identity says what? 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals 6.
Okay, yes.
Okay. Am I allowed to start here? No. Right? It would just be 1 plus 1 plus 1 doesn't equal 6.
Does it
right?
equal 6?
And that's the rule.
Then what would it have to go? Whoa, whoops. Okay. No pointer. What would it do?
The hockey stick identity, the rule is you gotta start up here, right? Let's look at another example of the hockey stick identity. Let's fill out Pascal's triangle a little bit more.
Okay.
This is a 1, this is a 3,
They're small.
1, 4, and I'm writing in a bigger, more, hopefully it'll be easier to see. 3 plus 3
Very.
is 6, 6 plus 4 is 10, and so on. Okay, let's just do a hockey stick identity, right? What's 1 plus 2 plus 3? 6,
6, okay.
right? What's 1 plus 2 plus 3 plus 4? It's 10,
Well, it worked.
right? But,
It's not that miraculous.
well, yeah, no formula really is miraculous, right?
This isn't really a formula.
So, anyway, this is 1, this is 5, 15, 35. So that's an illustration of the hockey stick identity.
Mm-hmm.
Okay. How are we going to use it in this particular problem? Let's look at let's go back to the identity itself.
Okay.
The identity itself tells us that if I add up all of these numbers, I get this number.
Okay.
Okay? And what are all of these numbers? Well, let's just circle them. All of these numbers in green add up to the number in blue.
Hi.
Okay?
It's not much of a hockey stick.
Well, it's an analogy. So, give it a break. All right, let's write out what does that hockey stick mean in terms of numbers? What is the uppermost number? And what number is this in Pascal's triangle?
What number is which one?
What number is this number? And what number is this number? And what are these first three numbers?
1, 5, 5.
No, I mean in terms of n choose k and all that. This number in Pascal's triangle, what's n and what's r? Or what's k?
What's K?
So remember, n goes down,
Okay.
right? 1, 2, 3, 4.
Okay.
N is 4. R, 1, 2, 3, 4. R is 4.
Okay.
So, and I'm going to use K and R interchangeably. This first term then is 4 choose 4.
Okay. Mm-hmm.
Do you believe that?
Yes.
Understand it. What's the next term? Well, it's going to be 5 choose 4. This number is 4 choose 4. This number is 5 choose 4.
Okay.
This number is 6 choose 4. 7 choose 4, 8 choose 4, all the way down to 15 choose 4. Okay? So the hockey stick says that 4 choose 4 plus 5 choose 4 plus 6 choose 4 plus all the way up to 14 choose 4 plus 15 choose 4 equals what? It equals this thing.
Okay.
This list, this diagonal column, if I'm going to write it out with numbers and add them all up, looks like this sum.
Okay.
Okay? With me on that.
Yes.
This is important.
Okay.
The hockey stick identity, the miracle of modern technology, is that all of it adds up to this number, this blue business right here.
Okay.
What is this blue number in terms of what choose what? So let's blow it up to
Thick.
if this number right here, and hold on, let me write it in. If this is 14 choose 4, and this is 15 choose 4,
Okay.
what we're doing is we're looking at these last few. So we're taking this part of the picture and we're blowing it up.
Okay.
And these last two sums form this end of the hockey stick.
Okay.
What is this dot in
What?
terms of numbers? After the hockey stick makes its little curly bit at the end, it lands on this number. What is this number in terms of Pascal's triangle? What choose what? It's this blue dot. This thing right here is this thing right here.
Okay.
What is that number? Because we have to write down the right-hand side of the hockey stick identity. Otherwise, we're not using this hockey stick identity machine, which we've studied so hard for 3 weeks now, trying to understand the hockey stick machine.
The hockey stick machine?
We got to know what goes on both sides of the equation. We know that on the left side of the equation, we've got all these things added up.
Okay.
All these right here added up. The right side of the equation is this dot.
Okay.
What is that dot? What choose what? So I'm putting it on you. This dot right here. What is it? So what's the top number? Is it 14?
The top number? No.
15?
No.
16?
You have to add them up.
I have to add. No, I'm talking about this number right here. Looks like N, choose R. Go to the book. Let's look at the formula in the book. Let's go back and in the book, this picture shows up as
N plus 1.
N minus 1 choose R. And then we have
It's
N choose
plus
R.
1 over.
And then this number is N plus
Oh.
1 choose R plus 1. Now does it make sense? In that we're looking at a specific example of what they write on, let me just say this thing in green is exactly the same as the example that we've been doing so far. It's just that I'm using N's and R's instead of 14s and 15s.
Okay.
Okay? So the question is, in the problem that we're given, we've got to find...
Whoa. This goes struggle so tiny.
We've got to find, so I'll even write it here, which will hopefully make things look... This number is 14, choose 4. Right?
Yes.
This number is 15, choose 4. We're adding all of these things up to make the mystery number.
The mystery number?
Well, it's a mystery so far because nobody's revealed who it is.
Who it is?
What it is. What goes here? What goes there? What numbers? Tell me what to write.
Sure.
Tell me what to write.
It's N over R. You said it's N over
Well,
R, so...
really in the book they call it n plus 1 over r plus 1. So maybe I should put a plus 1 here and a plus 1. So the audience is dying to know who did it. What combination of numbers goes here in the blue dot?
Did I take answer from the dot?
14, 15,
16?
16. Okay. Now let's look at this diagonal. If all of these are 4, all of these are what? If R is 4...
Then these must be 5s.
Right, okay. So that means all of these things that we just add up to 16, choose 5. All right, let's go back
Now the
to
audience
the
knows who did
mystery
it.
and say, okay, what does all this add up to? It adds up to 16, choose 5.
Okay.
Okay, now, let's think about why do we care? Because the original problem did not have what we introduced there, and I'll write it out what I mean. The original problem asked us 8 choose 4 up to 15 choose 4, and we decided, okay, we're going to put a 4 choose 4 here.
But they didn't tell us to.
5 choose 4 all the way up to 7 choose 4, right?
Well,
And we
weren't supposed
agreed.
to do that.
Well, I mean, we know that all of this adds up to 16 choose 5, right? But that's not what we're asked to solve, right? We're asked to solve this stuff right here.
Okay.
So that means we got to figure out what this stuff is so we can subtract it from 16 choose 5.
Okay.
So if we take this whole sum and we figure out 4 choose 4 plus 5 choose 4 plus 6 choose 4 plus 7 choose 4. Whoops. If we take, if we now figure out what this thing equals, the blue stuff, the turquoise blue stuff, and we subtract it from 16 choose 5, we will be left with the grand prize.
Okay.
So we're looking for the purple stuff.
Purple stuff.
That was our original goal.
Okay, and we have not solved it quite
We have not found it. What we did was we threw in some green stuff, right? And we said, okay, purple stuff plus the green stuff gives
blue stuff.
us, well, we changed green to blue. I don't know why I did that. Anyway, so maybe we'll go through and redo it.
Does it look great?
How about this? Oh no, now it's,
Well, function.
now I don't even know what's going on.
We just want
Here, let's just black it out.
Yeah.
Forget that. and let's redo it in green. Okay? 4 choose 4, plus 5 choose 4, plus 6 choose 4, plus 7 choose 4. Equals something. Okay?
Yeah.
Now we agree.
He's
All right.
big and black.
We agree that if I take the green and the purple, the green stuff and the purple stuff, I get 16 choose 5.
Okay.
If I can figure out what the green stuff is, I'm good to go.
And subtract it from this stuff.
Exactly.
Or this.
So now let's go back. Go back to the triangle.
I like it when it's small.
We're looking for this stuff.
Mm-hmm.
Where does it show up in Pascal's triangle? 4 choose 4 all the way up to 7 choose 4. So here, I'll turn on the red dot. Where's 4 choose 4 in the triangle?
0, 1, 2, 3, 4, choose. So it's gonna be here.
That's 4 choose 0 when you go down the left.
Oh, but it's gonna be here because it starts from 0.
That's 5. So look, if this is 0, so you did it right the first time.
0, 1, 2, 3, 4.
Right. But now you're doing 0. We need to do choose 4. You're trying to color. And it's
This
a
one?
laser. Right, exactly. This one right here is 4 choose 4. Where's 5 choose 4? Well, we don't have to go, so you're counting, remember, when you're counting top down, this is, oh, so you can count downwards and then count right to left if you don't want to count. Okay, count however you want. You be
Wait.
careful. 1, 2, 3. Here, let me do it. Let's do it with this. 1. And now that's angled wrong.
Whoa.
Here, there we go. 1. That's not 1 actually. That's 0.
Mm-hmm.
When I move the arrow, I'm gonna count.
0,
1.
1, 2, 3, 4, 5.
Okay, now we've got to choose 4.
Mm-hmm.
1,
1,
2,
3,
3,
4.
4.
And we are here.
Okay, now let's do 6 choose 4. Well, do we really need to do all that again? Or we can just go, boom, 6 choose 4. Because we know that along these diagonal lines, R is always the same. Okay, so this,
But not these.
no, R goes up 1 each time going this way.
Oh.
N goes up by 1 as we go down.
Okay.
And R goes up by 1 as we go left to right.
Okay.
Okay? So, what are we saying? This is 4 choose 4. 5 choose 4. 6 choose 4.
7 choose 4.
7 choose 4. That's what we were looking for. Remember? So we actually called, here, I'm going to do this. Uh-oh.
There.
This portion right here is exactly 4 choose 4, plus 5 choose 4, plus 6 choose 4, plus 7 choose 4.
Okay.
Okay, let's hockey stick this.
Hockey stick it?
Yeah. These 4 numbers add up to what, according to the hockey stick? So do it with the, we'll even zoom it in.
Whoa.
So now it's on the red pointer. These 4 add up to what, according to the hockey stick?
1, 5, 15.
No, I shouldn't have written the numbers, but
Okay.
I know what 1, 5, 15, and 35 add up to. But abstractly, according to the hockey stick, these 4 numbers add up to this number.
These 4 numbers.
That's what the hockey stick says. It says do this and then do that.
So these add up to this.
Not to this one. To this one.
Oh. So
This number plus this number plus this
They
number
got
plus
to.
this number adds up to this one. What are these in terms of n and k and all that? Well, if this is 7, choose 4, if this number is 7, choose 4, what's this number? Seven, choose 4. What happens when I go down? What happens to the top number? So go back to this picture. This picture right here. In our example that we're doing upstairs, this is 6, choose 4. This is 7, choose 4. What's this number?
um 8 over 5.
Right. So now let's take this knowledge and go back up to the triangle. Okay? This was 6, choose 4. This right here was 6, choose 4. 7, choose 4.
Okay.
6, choose 4, 7, choose 4, and then what's that?
8 choose 5.
8, choose 5. Okay. What does that tell us? According to the hockey stick, that 4, choose 4 plus 5, choose 4 plus 6, choose 4 plus 7, choose 4 adds up to what?
8 choose 5.
Adds up to 8, choose 5. Okay. Now, we're almost there. We're in like the final 5 minutes of the TV show. I know what the green stuff adds up to.
Now you just.
I know what the total
Yeah.
adds up to. I'm interested in the purple business.
The
Right.
purple business.
How do I figure out what the purple business is? All I have to do is subtract.
Okay.
Agreed?
Yes.
So what do I subtract to figure out the purple stuff?
You subtract 6. Are you on the pointer?
Mm-hmm.
You subtract.
It's okay. Leave it. The arrow's fine. Well, do whatever.
You subtract.
Get the hiccups?
Yes. Subtract this one from this one.
You said it backwards, but yeah.
Okay. So it goes 16 choose 5.
Oh, you wrote the fraction.
I know.
Everybody does that. I don't do the undo. For some reason, it doesn't work.
Huh.
Stupid program. Anyway.
16 choose 5 minus 8 choose 5 like this.
Equals the answer to 13.3. Okay. So, just to summarize, I'm just gonna.
To summarize, I wrote very big.
To summarize, I'm gonna do some dark stuff. We were interested in. We were interested in this purple stuff,
Whoa, it's very light.
right? We were interested in adding up this purple stuff. The hockey stick identity doesn't let us do that, right? We can't just start in the middle. We looked at that at the very beginning.
Okay.
To use the hockey stick identity, you got to start all the way up here and go down,
Okay.
right? So what we did was we said, okay, we're going to use the hockey stick identity with this hockey stick. Let's even do it. I'll even just do it. There's a hockey stick,
Okay.
right? Here's a hockey stick,
Hockey sticks.
right?
There are many.
When I
hockey sticks.
subtract these two hockey sticks, I'm left with the
That
purple
awesome hockey
stuff.
stick. It's a very colorful hockey stick.
Okay? So just to sort of finish out the whole problem, we took the blue hockey stick. From the blue hockey stick, we subtracted the green hockey stick. And we were left with
the purple
the purple stuff.
hockey stick.
Okay?
Okay.
And, okay, so we good on this 13.3?
Yes.
It only took us 2 weeks, right?